So today we're going to be looking at graphing linear inequalities. So the thing is, the solution sets for linear inequalities in two variables are pretty complicated. There's no good way of writing them down in a way that really helps you figure out what they are. So what we actually do is we graph them. And then by looking at the graph, you see what things are solutions to your linear inequalities, and then that helps you pick the ones that are beneficial to you. But these solutions in general are going to have an infinite number of solutions in them, these problems. So we have to figure out how we're going to represent that, and the best way to do it is by graphing them. Now, the hardest step in doing these types of problems is actually graphing the line. So if you're already comfortable with graphing lines, you're good to go. This is not going to be difficult for you at all. If you're still struggling with graphing lines, you got to get that under control, and then this will make a lot more sense to you. So let's consider the line y equals 2x minus 3. Remember, in that case, every point that lies on that line is a solution to the equation y equals 2x minus 3. Well, what if we change it to y is less than or equal to 2x minus 3? That means we want solutions that give us equality, y equals 2x minus 3, and we also want solutions that give us a less than condition, that satisfy that less than condition. So you can see that everything that satisfies y equals 2x minus 3 is also going to satisfy y is less than or equal to 2x minus 3 because of the or equals part. But we're going to pick up a whole bunch of new solutions by the less than part. And it turns out that the way this works is the line is going to split your plane here into two pieces. One of those pieces is going to end up being the solution, and the other side will not. But we don't know which one. Is this side the one that's the solutions, or is this side the one that's the solutions? We can't verify that yet. We don't know the answer to that question. Once we figure it out, we're just going to take the side that has the solutions and we're going to shade it in, okay, to specify that those are the solutions. So you can see already, hardest part is graphing the line. Once you do that, it's just figuring out which side I'm supposed to shade in, which isn't too bad. So let's say I want to figure that out, right? So we want to figure out what y less than or equal to 2x minus 3 is. Well, we've already graphed that boundary condition, the line that represents that inequality. We've already got that. So now we just figure out, do I shade this side or do I shade this side? How do you do that? Well, what you do is you pick a point that's not on the line. You can't pick a point on the line because you're going to get equality. You have to pick a point that's clearly to one side or the other of your line so that you can tell which side it's on, and you use that as a test point. You literally just test the point and then see what happens. So let's do that. One of the easiest test points to grab is 0, 0. So we've got this point right there. I can clearly see it's on one side of the line, so I can go ahead and use that as a test point. So how do we use a test point? You just plug that x and y value into your inequality, okay? So let's see, let's do that. I've got a 0 for x, I've got a 0 for y, and I'm going to plug them into this inequality right here, which would give me 0 is less than or equal to 2 times 0 minus 3. Is that true? So let's see. Is 0 less than or equal to 0 minus 3? That would say that 0 is less than or equal to negative 3. No, that's not true. Okay, so we got a false statement when we did this. So what does that tell you? That tells you that 0, 0 is not a solution. That indicates to us that nothing on this side of the graph is a solution. So then the assumption would be everything on the other side of the graph is a solution, which is true. So I'm just going to show you what it looks like when we try a test point on that other side. But we already know this is the side we should be shading, okay? So you don't have to test it twice like I'm going to do. I'm just testing it twice for instructive purposes so you can see me go through it 2 different times, okay? But you'll just test one point and then you decide if what you're getting is true or false, and then from there decide which side to shade. In this case, we got something that was false, so we would shade the opposite side. So what would happen here if we picked a point that was on the other side? How about if we pick, say, 4, 1? Okay, so now we're picking a test point that's on the other side. So when I go to plug that into my inequality, I'm going to get 1 is less than or equal to 2 times 4 minus 3. So let's see, that would be what? 1 is less than or equal to 8 minus 3. That would be 1 is less than or equal to 5. Yeah, that's true. That's true, which would mean we shade on this side. So notice how we got consistent outcomes. When we tried this point, it indicated to us, since we got a false answer, that we should shade the opposite side. When we tested this point, we got a true statement indicating that we should shade that side, the side that's on, because it's a solution. So both of these agree. We should be shading this side of the graph. So let's see what happens when we go through and shade that. We get, let's see, where is it? Right here. Yep, sure enough, it shades that side of the graph. So notice how it's got a solid line here. We've got a solid line, and then we've shaded this side of things. So that's all there is to graphing a linear inequality. It's actually all the steps you kind of know how to do already. It's just putting them together. So we've got graphing the line, a little bit of algebra when you go to use the test point, and then you just color in one side of the graph. That's all you have to do there. Notice how I just graphed y less than or equal to 2x minus 3. Well, what if we just had y less than 2x minus 3? So let's see how that changes when we go to this. Notice how the boundary line is now a dashed line. That's to indicate that the points on the boundary themselves are actually not solutions anymore. Okay, they're not part of the solution because we lost that equality. So the things that were originally solutions to the equation are not solutions down here because we're looking for things that are strictly less than. So that's how you know whether to use a solid line or a dashed line, is basically, do you have an equal to condition in your inequality? Okay. Now we're going to bump things up to systems of linear inequalities, and the good news is it's not any harder than what we already did. You're just kind of going to do it twice. So you do the step one time, you do the step again, and then you see where things overlap. So let's now take into account where we have our two linear systems here. Let's get rid of this one and this one. So the linear system is y is less than or equal to 2x minus 3. That's the inequality we were just using. And now I'm adding in a second one. Y is greater than negative 1/2 x plus 2. Okay, so we already worked on how to figure out this line and figure out the shading there. But now we want things that satisfy the second inequality as well. So we do the same exact thing. You're going to go through, you're going to graph y equals negative 1/2 x plus 2, and you're going to pick test points on either this side or this side of the line. So we can even ignore this for a moment and forget about it. So you kind of treat it like it's two separate problems. First take care of the first inequality, and then you'll take care of the second inequality. So for the second one, we're graphing this line. Pick a test point on either side. How about 1/2? If we plug this in, we'd get 1/2 is greater than negative 0 plus 2. That's not true, so it's going to be the opposite side. So when we go to graph that inequality, we can see we're going to get this, right? So again, just use a test point to figure out which side to shade on. And we're using the dashed line because, remember, we have a strict inequality here. It's not a greater than or equal to, it's just a greater than, okay? So how do we put these two together? Well, you can see if we graph both of these like this, it gets to be kind of a mess. This one isn't too bad. What you're looking for is ultimately the area that got shaded by all of the functions involved. In this case, this area got doubly shaded over here. That's the area that we actually want shaded. But we have kind of a mess here because here we have no shading. This one has some shading. This has some shading. And this has double shading. That especially gets confusing when you have like 3 or 4 or 5 of these things and you're trying to graph them all at once and they all have different levels of shading. It gets really confusing. Is our first line, then we've got that second line. So what you should do, especially if you're ever doing these by hand on a piece of paper, is don't shade things in. I see students do that sometimes where they'll give me a graph and they'll shade these more lightly and then they'll shade this region heavier. But as you can imagine, unless you're like an artist, it's just really confusing. Plus, you're not supposed to shade the parts that aren't doubly shaded. So what some people do is they'll just make a little note for themselves when they're writing this out. They'll put like a little dot on the side they're supposed to shade, or some people put a little arrow up here indicating, oh, I'm supposed to shade this side of the purple line. And then you do the same for the red. I'm supposed to shade this side of the red line. So rather than shade the whole thing in, you just make a little mark to remind yourself what part gets shaded. And then you look for the section that gets shaded by everything. And that ends up being this one over here. So your final answer should actually just look like that. Okay, see how I've only shaded this? It's not like earlier where we had this was kind of shaded and this was kind of shaded. The only shaded region should be the one that satisfied both of these inequalities, okay? So the good news is, like I said before, the hardest part about this is graphing lines. So if you've been following through, doing the work you're supposed to, and you can graph lines, you should be good to go with this. Feel free to use Desmos to help you out in this, but again, you should be able to graph lines by hand. Okay, you should absolutely be able to do that. So make sure you push yourself and that you can do that, okay? All right.